Good morning. These are very important results that we are going to prove. If f vector is a continuously differentiable vector point function in a region B, then first result, the surface integral of the cross product of f vector with n vector equal to negative of the volume integral of curl of f vector. Second, the surface integral of phi n vector is equal to volume integral of grad phi. So before starting with the proof, let's read these remarks which are very helpful in proving the result. The Gauss Divergence Theorem in terms of Cartesian coordinates can be written as the surface integral of f1 dy dz plus f2 dz dx plus f3 dx dy equal to the volume integral of curly f1 over curly x plus curly f2 over curly y plus curly f3 over curly z dx dy dz, where f vector is f1 I vector plus f2 j vector plus f3 k vector, right? Then is this Gauss Divergence Theorem holds good for the region V shaded. This is your shaded region V, and these are the normals directed away from the region. This is your surface S1 and this is your surface S2. For the surface S1, the normal is directed like this, which is away from the region. For the surface S2, the normal is directed like this, right? So the outward drawn unit normal vectors at any point means the normal directed away from the region. Okay, next, these are very important results. Please keep these in mind. First one is the dot product of the cross product of two vectors with n vector equal to the dot product of a vector with cross product of f vector n vector. How to remember this? If we are having the vector a, f vector and n vector, right? Then cross product of these two vectors, taking its dot product with this n vector, is equal to the dot product of a vector with cross product of these two vectors, right? Then second result, the divergence of cross product of two vectors is equal to the curl of the first vector and its dot product with the second vector. To remember the second result, just note that the cross product are taken near the equal to sign, right? Third result, a vector phi, its dot product with n vector is equal to a vector dot product with phi n vector. Then is the divergence of a vector phi is equal to a vector dot product with grad phi. So these are very important results and we are going to use these results in the proof, right? Okay, let's start with the proof. First, we need to prove that the surface integral of cross product of f vector with n vector is equal to negative of the volume integral of curl of f vector. Curl of f vector means del cross f vector, right? Okay. What Gauss Divergence Theorem is? Surface integral of dot product of f vector with n vector is equal to the volume integral of divergence of this f vector, right? So let's consider one constant vector. Let a vector be the constant vector. Let's use this theorem. For this, I'm going to replace this f vector with cross product of a vector with f vector. So we get the surface integral of, in place of f vector, just write cross product of a vector with f vector. And its dot product with n vector. ds equal to the volume integral of divergence of, in place of f vector, write cross product of a vector with f vector. So this implies, using this first result, that cross product of two vectors with dot product of n vector is equal to first vector dot product with cross product of other two vectors. So using the result over here, So it is surface integral of A vector dot product with cross product of F vector and N vector ds equal to the volume integral, okay, writing the divergence of cross product of two vectors as del dot A vector cross F vector dv, right? Okay, now using the second result over here, that is the divergence of cross product of two vectors is equal to curl of the first vector, its dot product with the second vector. So we will get curl of A vector, its dot product with F vector. Let me write the left hand side again. The surface integral of A vector dot product with cross product of these two vectors ds is equal to, applying the result, we get the curl of first vector, its dot product with the second vector dv. Now A vector is your constant vector. So taking this outside, and it can be written as A vector dot product with the surface integral of F vector cross N vector ds equal to curl of A vector is negative of A vector cross del. So this is negative of volume integral A vector cross del dot product with F vector dv. Now again applying the first result, that is dot product of cross product of two vectors with the third vector is equal to dot product of first vector with cross product of other vectors. So applying the result over here, so this is equal to negative of volume integral, okay, cross product of two vector, its dot product with F vector equal to first vector, its dot product with cross product of other two vectors dv. Fine. So writing this negative of volume integral A vector dot product with, writing this as curl of F vector. So this is curl of F vector dv. Taking this integral to the left hand side, so this implies dot product of A vector with the surface integral of F vector cross product with N vector ds plus dot product of A vector with volume integral of curl of F vector dv equal to 0. Taking this A vector common, so this implies A vector dot product with the surface integral plus this volume integral. And because A vector is your constant vector, we have taken A vector to be the constant vector, and also A vector is arbitrary vector. So for this dot product, this bracket must be equal to 0. So writing this, but A vector was arbitrary vector, therefore the surface integral of cross product of F vector and N vector plus the volume integral of curl of F vector is equal to 0. This implies the surface integral of cross product of F vector and N vector is equal to the negative of volume integral of curl of F vector dv. Hence, we have proved the first result. Now let's move on to the proof of the second result. That is, the surface integral of phi and vector is equal to the volume integral of grad phi. For this again we have to consider the constant vector A. So let A vector be the constant vector. And now again we have to use this Gauss's Divergence Theorem. Now I am going to replace this F vector with A vector phi. The surface integral of A vector phi, its dot product with N vector ds is equal to the volume integral of divergence of A vector phi dv. Right? Is it okay? Alright. Now I am going to use this third result, that is dot product of A vector phi with n vector is equal to A vector dot product with phi n vector. On the left hand side phi is with A vector, on the right hand side phi is with n vector. Please remember this. Let's use this result now over here. So we will get this to be as A vector dot product with phi n vector. Right? Okay, let's write this. So this implies the surface integral of A vector dot product with phi n vector ds equal to the volume integral of divergence of A vector phi. So writing this as del dot A vector phi dv. Is it okay? Alright. Taking this A vector outside, as this is your constant vector. So this implies A vector dot product with the surface integral of phi n vector ds equal to, okay, let's apply the another result over here. That is the fourth result. The divergence of A vector phi is equal to A vector dot product with grad phi. Right? So this becomes A vector dot product with grad phi. Right? So writing this, the volume integral of A vector dot product with grad phi dv. Taking this A vector outside of this integral, so we get A vector dot product with the volume integral of grad phi dv. Taking this right hand side to the left hand side and taking this A vector common, so we get A vector dot product with surface integral of phi n vector ds minus volume integral of grad phi dv is equal to 0. Again, A vector is your constant vector. So A vector was arbitrary vector. So for this dot product, this bracket must be equal to 0. But A vector was arbitrary vector. So therefore, the surface integral of phi n vector ds minus the volume integral of grad phi dv is equal to 0. This implies the surface integral of phi n vector ds is equal to the volume integral of grad phi dv. So we have proved the second result also. Let me write all these three results together, that is this one. So I am writing these three results together. For the Gauss's divergence theorem, I am taking the dot product of these two as dot product of n vector with f vector. That is the surface integral of n vector dot f vector ds. I have written n vector dot f vector instead of f vector dot n vector for the Gauss's divergence theorem result. So this is equal to the volume integral of divergence of f vector dv. Right? Then writing the second result as this result, which we have proved as the first result. The surface integral of cross product of f vector with n vector equal to negative of volume integral of curl of f vector. This result can be written as the cross product of n vector and f vector. Interchanging these two, if I interchange these two, the cross product, that will give us negative sign, which is cancelled out with the sign on the right hand side. So we get the result as the surface integral of cross product of n vector with f vector equal to volume integral of curl of f vector without this negative sign. So writing this, the surface integral of cross product of n vector with f vector ds is equal to the volume integral of curl of f vector dv. Right? And the third note, that is the second result which we have proved, this one. So writing this as, instead of phi n vector, I am writing this as n vector phi. That is okay. So the surface integral of n vector phi ds is equal to the volume integral of grad phi dv. So these are the three results which I have rewritten in another way so that it will be easier to remember the results. Let's read them again. So the first result is the surface integral of dot product of n vector with f vector is equal to the volume integral of divergence of f vector. Second, the surface integral of cross product of n vector with f vector is equal to the volume integral of curl of f vector. Third result is the surface integral of n vector multiplied with phi is equal to the volume integral of grad of phi. Right? So these are now very easy to remember. For the dot product, we are having divergence. For the cross product, we are having the curl. For the normal product, we are having the grad. So these three results are covering the divergence, curl, and gradient. Alright, thank you.